Here's a few more examples of antidifferentiation, and in these ones we'll be finding out the value of c. The first question here, if the gradient at a point on the curve is given by 5x and the curve passes through 0, 6, find the equation of the curve. Okay, so the information that we have here is the gradient, that's dy dx. So that tells us that the gradient is 5x, so dy dx is equal to 5x, or we could also be calling it that as well. It doesn't matter, dy dx or that. So what we're going to do is we'll say that our gradient function or derivative is equal to 5x. So what we need to do is to find the antiderivative. So the function of x will be equal to the integral of 5x dot dx, or antiderivative, which will be equal to 5x squared, because our power of x is 1, we have to add 1 to that, and then we also need to divide by the 1 plus 1, which is 2. So it'll be 5x squared over 2, and then we need to go plus c. Now we're going to find out what the value of c is, and to find the value of c we've got this other bit of information. The curve passes through 0 and 6. So I need to take that 0 and 6 and substitute that into here. So when y is equal to 6, x is equal to 0. So I'm just substituting my x and y's into there. 5 times 0 squared, that's just all 0, so we don't have to worry about that. That tells us that c is equal to 6, and therefore that means our function of x will be equal to 5x squared over 2 plus 6. That's the answer to this one. Okay, let's move on to the next example. Find y in terms of x if dy dx is equal to x squared plus 2x and y is equal to 1 when x is equal to 1. So, same process, we have y will be equal to the antiderivative of x squared plus 2x with respect to x, and that will be equal to x, we go 2 plus 1 will be 3, so that's x cubed, and we need to divide that by the power, so divide that by 3, and we go plus, we have 2x, this is already a power of 1, so go 1 plus 1, which will give us squared, so it'll be 2x squared. We have to divide it by that new power, so divide it by 2, and we have to go plus c. Do a bit of simplifying here, those 2's will cancel out, so it tells us that this will be equal to x cubed over 3 plus x squared plus c. Now we need to get this other information here. When y is equal to 1, x is equal to 1, and that gets substituted into there. So it tells us that 1 will be equal to 1 cubed over 3 plus 1 squared plus c. And let me just reduce the size of that a little bit. A bit more room to work on now. So 1 is equal to a third plus 1 plus c. Now if I take away 1 from both sides, we'll have 0 is equal to a third plus c. Let's take away a third, c will be equal to negative a third. That means that our equation will become y equals x cubed over 3 plus x squared, take away 1/3. And that's the answer to that one. Let's move on one more example. Find y in terms of x if dy dx equals 3 take away x, and y equals 2 when x is equal to 4. So same process again. Y will be equal to the antiderivative of 3 minus x with respect to x, which will be equal to 3x. The way that works is, in this instance here, this is 3x to the power of 0. X to the power of 0 is just 1, so we're going to be adding 1 to the power there, which gives us 3x to the 1. And the second term there is take away x. This started off as x to the power of 1, so we have to add 1 to the power of that, which gives us x squared. But we have to divide by the new power as well. And then we go plus c. Now, in order to work out what our c value is, we have that needs to be substituted into there. So 2 will be equal to 3 by x is 4. Take away 4 squared over 2 plus c. Simplifying this down a bit, 2 is equal to 12. Take away 4 squared is 16, divided by 2 is 8, plus c. 12 take away 8 is 4. So 2 is equal to 4 plus c. Take away 4 from both sides gives us c is equal to negative 2. So that will now tell us that our equation is y equals 3x take away x squared over 2 take away 2. Hope you find that useful.